network. Using topology diagrams, we can see the devices in the network, including end devices, such as desktops and servers, and intermediary devices, such as switches and routers. These diagrams may also contain detailed information about a device, such as the MAC address of the Ethernet and wireless NICs, IP or Internet Protocol address information, default gateway addresses, and addresses for the DNS server. By the way, don't worry about what these terms and addresses mean right now. All of this will be explained throughout this course. This is how we see the network, but how do devices see the network? You can think of it as every device being in its own bubble. The only thing a device knows is its own addressing information. In other words, this is how a device sees the network. It doesn't. So, how does a device know its IP address and what network it belongs to? How does a device know if the destination device that it needs to send information to is on the same network or another network? If the destination is on another network and the information has to travel through intermediary devices, how does the source device know where to send it next? How does the source device know if the information it sent was received or if it needs to resend anything that might not have reached the destination? The answer to all of these questions is protocols, the rules that govern how devices communicate. Most network communications are broken up into smaller data units, which we can refer to as packets. When packets are sent on a network, many protocols are involved to help them reach their final destination, each accomplishing a different task. There are protocols such as Ethernet and wireless protocols that physically connect the device to the network. The protocols DHCP and ICMPv6 provide IP addressing information, including IP addressing that tells the device what network it belongs to, the address of the default gateway that tells the device where to send packets that are destined for another network, and the address of the DNS server for when a device knows the domain name of a destination but needs the destination's IP address. For instance, when a user requests a web page from a web server, such as www.example.com, the device asks the DNS server for the IP address of the domain name www.example.com. IP is used to deliver the packet from the source of the information to its final destination, in this case the web server, similar to sending a letter. The web server will then respond back with the requested web page. TCP is a protocol used to guarantee reliability. In other words, to make sure all the information that was sent was received, such as the information that makes up the requested web page. If any of the IP packets don't make it to the destination, TCP resends them. So although we see the network like this, remember, it's a combination of many different protocols that allow devices to really see their place in the network and how to communicate with other devices.